Hello everyone, this lecture is about power, Rtotal and Rtotal. So let's look at this circuit that you're looking at right now. It has two branches. This circuit is in parallel, so we can't just add up our resistors to get Rtotal. And I want to find Rtotal and Itotal of this circuit. Now the key thing to realize in this case that right now I don't care about I1 and I2. I know that I1 and I2 exist, right? They flow through these branches. But for whatever reason, right now, I don't want to know about them. For your semester projects, you probably will. But right now, I don't care. So I don't want I1 and I2. I just want Rtotal and Itotal. So to find Rtotal, I'm going to use the big formula. The formula for Rtotal for circuit in parallel is 1 over Rtotal equals 1 over R1 plus 1 over R2. This formula is actually very easy to use as long as you're being very careful about it. So I'm going to go ahead and do that right now. I have 1 over Rtotal. This is 1 over 100 plus 1 over 100 because my R1 and R2 are each 100 ohms. So this is 0.01 plus 0.01. It's 0.02. The key is to understand that this number is not my final answer. This is just 1 over Rtotal. To find Rtotal, I need to divide 1 by the previous answer. So I'm going to go ahead and do that. So 1 divided by 0.02 equals 50. All right, let's put this in. This is 50 ohms. Now, notice that my answer is smaller than my branches. This makes perfect sense, right? As long as my answer is smaller than either of my branches, my answer is probably correct. So now I'm going to use my answer to find Itotal. So Itotal equals to voltage of the battery over Rtotal. I'm just using Ohm's law in here. This is nothing more difficult than Ohm's law. Well, it didn't work. Over Rtotal. Okay, so let's plug in some numbers. My voltage of the battery is 6 volts. And I'm dividing this by 50 ohms. And I'm going to pull up my calculator and see what that is. So 6 divided by 50 is 0.12. So my Itotal is 0.12 amps or 120 milliamps. That's a lot of current. So the next thing I want to know is how fast this current is going to drain my battery. Or I also want to know how much power does my circuit draw. But before we do this, we need to define power a little bit, because right now we don't really know what it is. So I want you to consider these two people. On the left side, you have J.J. Watt, and on the right side, you have Tweety the bird. Now let's imagine you have a heavy box that you have to carry across the football field. Now, which one of them do you think will get to the end of the field faster? JJ Watt or Tweety? Well, the answer is probably JJ Watt because looks like he's a lot stronger, right? Now, here's the deal. Tweety will also get to the edge of the field eventually, but it's gonna take him a lot longer. So we say that JJ Watt has more power than Tweety because he can do the same task faster. So I'm gonna go ahead and actually type this up. Now, being faster is the key word over here. Turns out power is nothing more than how fast you can do work. So here's my official definition. Power is the rate at which work is done. But wait just a second. What's rate? Rate means how fast. So I'm going to put it in parentheses. How fast? Well, the next question is, what is work? Because what's work for one person is fun for another. For example, I'd love to drive a race car just for kicks, you know. But for some people, it's a job. They're called race car drivers. But I think the key thing when you're considering work is to think about how much energy you're actually using it. We all do things that are quite fun that make us tired. We don't think of these things as work, but energy is used in those when we're doing that stuff. So let's alter our definition, and I'm gonna put down underneath the work, energy is used. Because when you get down to it, work is just energy applied to a task, right? So the energy is being used. So now our definition reads, power is how fast energy is used. That makes sense. So when you think of voltage, current, and resistance, it's worth remembering which one is energy. And energy is, of course, voltage, right? Remember, voltage is how much energy each charge has. So it's energy over time, over charge. Now, current, on the other hand, is a rate also. Current is charge over time, how fast the current is flowing, right? Now, when you look at power, if you're looking at how fast energy is used, then power is just energy over time. So when we put all of these things together, we're going to end up with a very interesting expression. Power equals current times voltage. And let's see if this really works out. So let's see. I said current is charge divided by time. Okay. And we're multiplying this by energy divided by charge. Well, the charge cancels out, doesn't it? You can cross out charge, and then I'm going to end up with energy over time, which is power. That's perfect. Now, the next question we have is, what are the units of power? Well, there is a reason I showed you a picture of JJ Watt in there, because the unit of power is called a watt. And we have capital W. And no, it's not named after JJ Watt, but it is named after someone who has exactly the same last name. And of course, if we want to put this as energy per time, 1 watt is 1 joule per 1 second. So it's really energy per time. All right. So now that I've got my units and I've got my formula, let's actually go ahead and use that formula in our circuit. So what is the total power of my circuit? Well, power total is going to be I total times voltage of the battery. My total current times my total voltage. That makes perfect sense. And of course, guys, voltage of the battery is your total voltage. You can't have more than what your battery have. Okay, so let's go ahead and calculate this. So I have 0.12 amps times 6 volts. And when I pull up my calculator, that's going to be 0.72 watts. 0.72 watts. And I'm going to convert this into 720 milliwatts. So that's my total power of my circuit. Awesome. But I don't really so much want to know total power right now, as I actually want to know the power floating through one of my resistors. Turns out resistors can be burnt out, and you can damage your resistors if you exceed its power rating. So what is a power rating? A power rating of the resistor is how much power you can put through that resistor before it starts melting down and doing all sorts of weird things. So let's figure out what power rating do we need for this 100 ohm resistor. So in order to find the power, and in this case I'm looking for P1, I need to know I1 and I need to know V1, V of R1. Okay, well, this is a parallel circuit, so V of R1 is going to be just 6 volts, because in that particular loop, we have only 2 circuit elements, the battery and R1 itself. So this one is 6 volts. And then I'm just going to use this 6 volts and divide it by 100 ohms. And I'm going to get 0.06 amps or 60 milliamps. All right, so now I've got my current, I've got my voltage, I can do P1. So this is 0.06 times 6, which is going to come out to 0.36 watts or 360 milliwatts. So let's look at my resistor. Resistors come in several varieties. Some of them come in 1/8 watt rating. This is just 0.125, right? Some of them have higher rating. So we need to choose the right one.